Hello, today we are going to be talking about proportional and non-proportional relationships from a graph. So the two things that you need to know about whether a graph is proportional or not, and it has to have both of these, okay, is, let me get a highlighter so I can highlight it. If a graph is proportional, that means that you have first a straight line. If you do not have a straight line, that means that it's not proportional. Okay, so that's the first requirement, is that you must have a straight line. The second requirement is that it must go through the origin. So remember, guys, when we talk about the origin, we are talking about the point 0, 0. So it has to go through that point 0, 0. So if you have a straight line and it goes through the origin, so it goes through 0, 0, that means that you have a proportional graph. So we can be able to look at a graph to determine if it is going to be proportional or not. So let's look at their first example that they gave us. So this says that the slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. So 6 feet per minute is our unit rate, so our slope. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. So they first made a table for 0, 1, 2, 3, and 4 minutes. So 0, 1, 2, 3, and 4 minutes. And they saw that if a sloth moves 6 feet per minute, at 0 minutes, that means that the sloth did not move any feet whatsoever. So there's your order pair 0, 0. Okay, so that's represented by this right here. Then, at 1 minute, if the sloth moves 6 feet per minute, that means that it moves 6 feet. So this ordered pair would be 1, 6. Next one at 2 minutes, so if it moves 6 feet per minute at 2 minutes, take 6 times 2 and that would give you 12. So that's the order pair 2, 12. And then you can see how they got the rest of their numbers here. So at 3 minutes, 3 times 6 was 18. 4 minutes, 4 times 6 was 24. So once they created their table, they then started to graph their order pairs on the coordinate plane and then connected the order pairs together to create a straight line. So 0, 0 was their first point, so they put a point at the origin. 1, 6 was their next one, so 1, 6 was right here. Next one was 2, 12. At 2 minutes, it was 12 feet. 3 minutes, it was 18 feet. And 4 minutes, it was 24 feet. So looking at the graph, is this graph proportional? Well, let's go back to the two requirements that it must have in order for it to be proportional. In order for it to be proportional, it must go through the origin. So it did go through 0, 0, so there's one requirement. The second requirement is it had to be a straight line. So was that a straight line? It sure was. So since it had both requirements, we say that this graph is proportional. Now, next week we are going to be talking about direct variation with proportionality. And if you have an equation that's in the format of y equals kx, where k is your slope, or in other words, your unit rate, we said from up here at the very beginning that the 6 feet per minute was our unit rate. So all that we would do is we would just plug in 6 for k, or 6 over 1 for k, 6 feet per minute. And I can tell from this equation that it is proportional because it's in this format of y equals kx. Okay, so again, we're going to talk more about this next week, but this is just an introduction to what you guys will see later. Okay, so let's try one on our own. James earns $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane, and explain your reasoning in the work zone. Okay, so let's do what they did up top by first creating a table. And how about we use the same numbers that they did? So let's say x is, as you guys can see, X is represented by time, so I'm going to put time first. And then Y is represented by the amount, so I'm going to put the amount on the bottom. And let's use the numbers 0, 1, 2, 3, and 4. And let's figure this out. So if James earns $5 an hour babysitting and he works 0 hours, how much money is he going to get paid? $0, right? If he did not work, he's not going to get paid. He's not going to get paid anything. Okay. So let's look at the next one. So if he makes $5 an hour and he works 1 hour, how much money is he making? Well, he's making $5. What about if he works 2 hours? Well, $5 an hour, 2 hours, 5 plus 5 gives us 10. Let's see the next one. So 3 hours, 5 times 3 is 15. And for 4 hours, 5 times 4 is 20. So again, the reason why we created this table is because this will help us graph this on our coordinate plane. So let's go ahead and do that. So at time 0, he would not make any money. So that would represent the point 0, 0. So everybody put a point at 0, 0 on the graph. Then our next time was for 1 hour. He made $5. So go over 1 hour on your x-axis and then go up to 5 on your y. So 5 would be in between 4 and 6 here. Then at 2 hours, it would be $10. So over 2, up 10. 3 hours would be 15. So over 3, up 15. And then 4 hours would be 20, but we don't have 20 on our graph because our y-axis does not go up to 20. So this right here would just be our line. So let's go ahead and connect our points. I should be using a ruler, but I don't have it near me, so I'm going to try my best to create a straight line here. Okay. So is this graph proportional? Well, let's think about it. The two requirements that makes a graph proportional is 1, is it a straight line? I know mine's not perfect, but is it going to be a straight line? Yep, it is a straight line. Okay. Then our second requirement is, does it go through the origin? So does it go through 0, 0? It sure did. So is this graph proportional? Yep. So we would put proportional because, and I have to put both requirements because I can have a straight line that doesn't go through the origin. So that would not make it proportional. And I can also have something that goes through the origin, but it's not a straight line. So when you guys go to explain why it's proportional, please make sure that you write down both requirements. So it's proportional because it's a straight line, and it goes through 0, 0. So proportional because it's a straight line and it goes through 0, 0. The next part, so let's just practice direct variation equation. So remember the equations y equals kx, where k is your slope. So if you have a proportional graph, all that you have to do is plug in your unit rate for k, which is your slope, and then just rewrite the equation. So what was our unit rate over here on our graph? How much did they make for 1 hour? He made $5 an hour. So your unit rate is that 5 over 1. So all that you would do is plug in 5 for k, and your equation would be y equals kx. Sorry, 5x. Y equals 5x. Alright, so let's move on to the back side. So an example here that they gave us is the cost of renting video games from Games Incorporation is shown in the table. Determine whether the costs are proportional to the number of games rented by graphing on the coordinate plane and explain your reasoning. So for one game, it cost $3. 2 games, it was $5. 3 games, it was $7. And 4 games, it was $9. So again, guys, these create order pairs for us. So at One game, it was $3. So as you guys can see on their graph, at one game, they went up 3. So one game, $3. The next one was 2 games, $5. Next one was 3 games, $7. And the last one was 4 games, $9. So if you look to determine if this was proportional or not, remember our 2 requirements is, did it make a straight line? It did make a straight line, so it did have that requirement. But did it go through the origin? Because that's our second requirement. It did not. It did not go through the origin, because if you guys see, there's no point at 0, 0. So since it did not go through the origin, we say that this is non-proportional. Okay, and another way that you guys could have checked to see if this was proportional or not is, remember what we talked about yesterday with finding proportionality from a table? Is if you were to set up these ratios, so this would be 3/1, this would be 5/2, 7/3, and 9/4. And if you guys were to find the unit rates of these, 3 divided by 1 is 3, 5 divided by 2 was 2.5, 7 divided by 3 was 2.3 repeating, and then 9 divided by 4 was 2.25. So were these proportional? Were these equivalent ratios? They were not. So that's another clue on how we would have known that this is not proportional. So again, we're taking what we learned yesterday with proportionality from a table and realizing what that looks like on a graph. And again, those 2 requirements is it a straight line? And does it go through the origin? Okay. So one more example here. So the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane, and explain your reasoning. Okay, so let's go ahead and start graphing these on the coordinate plane. So our first point is at 0 minutes, we have 0 calories. So this would be 0.00, 0 minutes, 0 calories. The next one would be at 1 minute, we have 4 calories, so go over 1 and up to the 4 calories. Next is we have 2,8, so if we go over 2 and up 8, that's right there. And then our last one is 3,13, so over 3 and up 13 would be right here. So let's see what this graph looks like. So if I were connecting my points, these make a straight line, but then this kind of goes up to the top a little bit. So it kind of curves right there. So is this graph proportional? So let's think about the 2 requirements. Does it go through the origin? It did. It did go through the origin. But is this line straight? I know it's close, but it's not straight. So since it's not straight, we say that this is non-proportional, because we did not have a straight line. And again, we could have looked at our table and noticed that it was not going to be proportional, because if I were to find my unit rates here, 4/1, 8/2, 13/3, if I were to reduce these, 4 divided by 1 is 4. 8 divided by 2 is also 4, so these were proportional. However, if you were to take 13 divided by 3, it gave you 4.3 repeating. So since this did not equal our other 2 ratios, we knew that this was going to be non-proportional. Okay? So the main thing that you guys need to take from today's lesson is knowing the 2 requirements that make a graph proportional. Is 1, your graph goes through the origin, and 2, your graph is going to make a straight line. So if you don't have those 2 things, then it is not going to be proportional. And another thing that I want to hint on is if you have a non-proportional graph, you are not going to have that y equals kx equation, because there's no unit rate that we can plug in for k. So this would not be happening. Okay? All right, as always, if you guys have questions, ask your teacher. Thank you.